Hello everyone and welcome. My name is Jason Gregerson, and in this video we're going to talk about work. Recall from class that work is essentially the force required to move an object times the distance the object is moved. If the force is constant, for instance if we apply a force of 2 newtons to a box and it moves that box 4 meters, then the work can be calculated through multiplication. And we would say the work done is 8 Newton meters or 8 joules. However, if the force is not constant, but rather some function, in other words, the magnitude of the force is changing as I move the object, well then we can't calculate this through direct multiplication. But rather, we could look at a thin slice and say just over that thin change of x, we could approximate the work done in just that little slice. To do that, the force in that little slice would be about constant, and then we would multiply that by the little change in x, in other words dx, and this would represent a little slice of the total work. From there, to calculate the total work, we would just add up all of our slices. And this is how we get the formula for the integral as a means to calculate work. A common application is to calculate the work needed to empty a tank of water. Consider the tank below, whose face is the parabola y equals x squared, and has a length of 5 meters. If a pipe pumps the water out to a height of 6, what is the work required to empty the tank? I'll start with the things I know. I know work is equal to force times distance. I also know that the density of water is equal to 1,000 kilograms per cubic meter. Now the force required to move the water out of the tank is essentially the weight of the water. But unfortunately I can't just calculate the weight of all the water in the tank and move it some distance to calculate the work, because the water at the top of the tank is closer to the top of the pipe, whereas the water at the bottom of the tank is farther from the pipe. So I do need to cut a thin slice of water. Now throughout that slice of water in my tank, I would be moving all that water the same distance. So, to approximate the work it takes to move the water out of this thin slice, I'll start by calculating the volume of the slice, dV. Now to calculate the volume of the slice, it should be the width of the front times the length times the thickness of the slice. Now if that slice is y units high, then the thickness of the slice is a little change in the y value. In this case, the length is a fixed value of 5, and I only need to really calculate the width. Now, the width, half the width, will be the distance from the axis out over here to the curve. That is the x-coordinate of that point on the curve. And since that curve is y equals x squared, I could solve that for x to get x equals the square root of y. And that would represent the distance from the axis over to the side of the trough. Now the total width is 2 times this value. So w, the width, is 2 times the square root of y. I now have width as a function of y. This gives me a good expression for dV. Now to calculate the work it takes to move the water in that slice out, I need to take the volume, 2 times the square root of y times 5 dy, and if I take that volume and multiply it by a density, my 1,000 kilograms per cubic meter, in this case the result would be a unit of mass, kilograms. If I take that mass and multiply it by the force of gravity, 9.8, this should give me a force, the force required to move this water. How far am I moving the water? Well, if the slice is at a height y, then the distance to the top of the pipe would be 6 minus y. And this would be a good expression for the work it would take to move the water out of this slice. To get the total work to empty the tank, I would be adding up all the slices over a range of y values, in this case y equals 0, to the top of the trough, the top of the tank, which is y equals 4. And this would be a good value for the integral needed to calculate the work it takes to empty the tank. Now certainly in Mathematica, I could just calculate that using the integrate command or in an integrate command. Now in our assignment, what we'll do is exploring other cases. For instance, what if I know how much work I'm capable to do, but I want to change the length of the pipe that I'm using to drain the tank? Another example might be, does the shape of the trough matter? What if I had the same amount of volume, but in a trough that was a little bit wider or a little bit skinnier and taller? So we're going to investigate those problems in the assignment. All right, that concludes this video. Thanks for your time.